I'm here. Hello, I'm here. Okay, we got to get through this because the Steelers play at 5. Got my Steelers shirt on. I'm ready for the game. So, yeah, I can tell you guys are excited. Let's see. Share my screen. Advanced. All right, so we were doing section 5. Let me see. Dun, 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 dun. Bum, ba-da-bum. I think I just a couple to go. All right, so we were on this one. Close this, get it out of the way. Y'all can hear me, right?
Yeah.
Okay, cool. Get my pens. All right, so they want you to write the expression as a single logarithm. And so the first thing you're gonna do is take any coefficients, which this is a 4, and that's the only one, and you're going to move it back up here to its exponent position. So this is gonna be, whoa, that's too big. This is gonna be log base 3 of an x plus 5 raised to the 4th minus log base 3 of x minus 20 minus log base 3 of x minus 15. And then because I have a subtraction sign here and also a subtraction sign here, anything that's behind a subtraction sign goes in the denominator. So as a single logarithm, this is going to be log base 3. And then here's the denominator, or the fraction bar. And above it will be the x plus 5 to the 4th. And below it will be both the x minus 20 and the x minus 15. And if there was any way to reduce that, I would, but there isn't, so I can't, and it's ugly, but that's my answer. Have fun typing that into my math lab, but you've condensed it down to a single logarithm. And this skill that you're learning in this section is going to be applied in the next section, 6.6, which we'll be doing today, where we have to solve equations, logarithmic equations. And in order to do that, you have to condense down multiple logarithms down to a single logarithm so that you can then convert it from log form to exponential form. Isn't that exciting? We're actually going to use this today where it says, basically before where you would drop the logs, we're actually going to be putting them back in, which is what this is saying. If you have two things equal to each other, then the log of those two things will still equal each other. We did this when we had log of this equals log of that, then this equals that. It works both directions. You can either drop the logs on both sides, or you can put the logs back in on both sides, whatever it's going to take to solve it. Because some things can be solved exponentially. And then if you can't solve them exponentially, you change them to log form and go that route. And then sometimes you're given stuff in log form, which you can't solve. So you change it from log form to exponential and solve it that way. It just depends. So they're interchangeable, and it's just whichever way gets you there. And then the last thing on this was evaluating logarithms whose base is neither 10 nor e, because in your calculator, base 10 is the LOG button on your calculator, and base E is the natural log button on your calculator, because this is really log base 10, and this is really natural log base E. But the bases are invisible. You just have to remember that if you see an log and there's no visible base, it's really an invisible 10. And then natural log is always base E, always, and nothing else. So, you know, if they're in base 10 or base E, you know, hey, I can grab my calculator and just use those buttons. But if they're not, you have to use something called the base, or I call it the base change formula. This textbook calls it the change of base formula. You're changing the base, all right, base change. And basically what it says is if you have, I'm going to write it myself, if you have log base A of something, can be a number, a letter, or an algebraic mess, that is actually going to equal the log of the whatever it is you're taking of divided by the log of the actual base A. Now, they put little b's in here. I don't know why, because I mean, I suppose you could use any base you wanted to. Like you could say log base 3 right here. Okay, you could. Or you could say log base 7 on both of these. You could pick any base you want, but the only problem with that is your calculator doesn't do those bases. It only does base 10. So this right here is actually the one you want to look at. And it also works with natural logs. So either calculator button will work. But if you choose to use regular log with your numerator, you got to use regular log with your denominator. Okay, if I do log here, I got to do log there. If I choose to use natural log here, I have to use natural log there. You can't do an log in the numerator and ln in the denominator. Wrong. Can't do that, okay? It's got to be consistent. And basically what you're doing is, let me pick two other colors. When I see this thing right here, I am going to take the log base 10 of the m. That's going to be my numerator right here. And then the denominator is going to be, and I was kind of drawn at an angle, it's this right here, log base 10 of a. That's what this is. And that'll actually calculate log base whatever of whatever. So if you're given log base 2 of a 3, I'm going to calculate log base 10 of 3 divided by log base 10 of 2. And I would just grab my calculator and do the math. So you're taking the log of the 3, that's the numerator, log of 3, and then you divide it by log of 2. I know over here on the left side of the equation, or the equal sign, that's log base 2, but it becomes log of 2. They'll both be base 10s in the numerator and the denominator. So looking at their example, use to change your base formula, approximate, round answers to 4 decimal places. And I'm going to have to write out what it is you do on your calculator. So let me rewrite this. It's log base 5 of 89. But that is going to become, you're going to take the log of 89. That'll be your numerator. And then the log of 5. Now, you guys have you're supposed to have the TI-30XA, which is a good calculator, but it's not the best as far as typing things in exactly as you see them. So step by step for this problem, I'm going to have to type in, this is my calculator steps. you start with the numerator and you're going to type in an 89. Then you're going to hit that LOG button. Then you're going to hit the division sign. I'll do that in black. The division sign. And then you're going to hit the 5 and then hit the log button again. And then you will hit your equals button. And when I do this, I'm hitting 89. LOG is in that top row, dead center. And then hit divide by 5 log. And then you have to hit the equal sign, because when you hit 5 log, you'll actually see the answer to just a log of 5. So hit equals, it'll go back and do the division, and it's going to display 2.7889465585. And they want us to go to 4 decimal places. So 1, 2, 3, that's the 4th decimal place. Because the next number is a 4, that'll stay as a 9. So I should get 2.7889. And the next slide shows their answer. And let's see if I match. There it is, 2.7889. Now, they wrote out all the intermediate steps, so if that's helpful for you, go ahead. When they calculated the log of 89, it gave them this number. And when they calculated the log of 5, it gave you that number, which, you know, I saw both of those numbers on my calculator screen. And then when I was done, it gave me this. Now, here's the weird part. If you use the LN button, the natural log, it gives you a different number for the 89 and so for the 5. But when you complete the division right here, you actually get the same answer. So that's how you use the change of base formula. And then there's another example of theirs. I want to go to my math lab so I can get through this. We had 2 more to go, 22 and 24. 22 says use the change of base formula. So I always like to rewrite it bigger. Log base 5 of 35 is going to equal, I'm going to take the log of the 35 and divide it by the log of 5. Remember, these are both base 10s. So on my calculator, I'm going to have to type in 35, hit the LOG button, then hit the division button, then hit 5, then hit LOG, and then hit your equal sign. And I should see 2.20906195. Now this time it says round to the nearest thousandth. I need to do that in a different color. Hang on, nearest thousandth. So tenths, hundredths, this is the thousandths. Because the next number is a 0, it will not change. So my answer is 2.209. And that's what goes in this box. And that little squiggly equal sign means approximately. And then this one used the change of base formula. Because of that square root of 19, I actually went ahead and did the intermediate steps on this because it was just, this calculator is not my favorite, but you've got log base square root of 19 of a 19. So you're going to start with the log of the 19. That's your numerator. And then you'll take the log of the square root of 19. And so on this one, what I did is I hit 19 and then log for my numerator. And then for the denominator, first you have to hit 19. Then you have to hit the square root button. And then you have to hit the log button. All right. And if I keep track of those numbers, log of 19 was 1.278753601. And the log of the square root of 19 was 0.63933768. And then I typed those numbers in and did the division in between. So, and that gave me 2 and there was like a gazillion zeros after that. And then I don't know what it said, but it's still to 3 decimal places. And so 1, 2, here's the 3rd decimal place. The next number is a 0. It would just be, you have to type in, I think it wants all 3 decimal places. So 2.000. Although I circled 2 on my paper. But my experiences with my math lab is if you don't do what they say, they get all jacked off and give you an error message. So I would type in the 2.000 just to show that you went out to 3 decimal places. Don't want to make the math lab gods angry now, do we? No, we don't. All right, so that finishes up 6.5. You guys got any questions before I jump over to 6.6? All right, take that as a no. Let's see, 6.6. Get this in the screen. All right, so here we are, section 6.6, and there's only 2 objectives. We're now going to solve logarithmic equations, and at the end, there'll be a few more exponential equations to solve. All right, so objective number 1, solve logarithmic equations. Okay, we've seen this one before. If y equals log base a of x, that is equivalent to x equaling a to the y. Remember, let's see, I don't remember what colors I used. I think I used pink. Remember that your base right here is the same base in exponent land. And your whatever your logarithm is equal to, that is your exponent in exponent land. And then whatever it is you were taking the log of, that is what your exponential thing is set equal to. Seems like before it was on the other side. It looked like they had, I think they had log base a of x is equal to y, and then they had a raised to the y is equal to x. They're messing with you and they switch sides. Do you see that? They just switch sides here and they switch sides there, but it's the same formula. And then the first type of logarithmic equation is if you have the log of something equals the log of something else, and both of those have the same base, it's log base a and log base a, you can literally just drop the log base a and you're just left with the m equals the n. So this is similar to when we had, if you had x to the a equals x to the b then the A just equals the B. And I said, you could drop your base. And then I asked somebody to drop the base and nobody would drop the base for me, you know? Well, this one's a little bit more inappropriate because, you know, you're going to drop your log on this one.
That was not funny. I want to tell you right now.
My daughter's booing me. All right, so you just drop the logs. So here's their first example. Solve this one. I see I have 2 times log base 5 of x equals log base 5 of 9. I got a log equals a log, which means I can drop the logs. However, you cannot drop them until, see this guy right here? Since he is multiplied onto the log, we have to first move him back to his exponential spot. So I'm going to rewrite the left side as log base 5 of an x to the second, and then that'll equal log base 5 of 9. And since I got the log base 5 of this equals the log base 5 of that, I can just drop the log base 5s. And I will have x squared equals 9, which is a quadratic. And I'm just going to go ahead and square root both sides. I'll use that method instead of factoring. And you have to remember when you take the square root, you have to consider either the positive or the negative of 3. However, if you plug in, so you're like, okay, I got x is equal to 3, x is equal to negative 3. However, different color, x equals to negative 3 doesn't check right here. You cannot take logs of negative numbers. You can try it if you want in your calculator. Negative numbers. So that one gets thrown out. This one should work. And now that you know the base change formula, you could check those if you wanted to. If I did on the right side, log base 5 of 9, that would be 9 log divided by 5 log, which gives me on the left side 1.365 blah, 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 blah. And then on the left side, I got an answer of 3. 3 log divided by 5 log equals, and then take that times 2. And well, look at that, 1.3652, blah, 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 same damn number. So it checked, woohoo. But of course, when you're doing my math lab, they'll check it for you. But it's a nice way to know on a test. And then of course, here is their explanation and how they did it, which looks very similar to mine. So, all right, another example. Okay. This one, I cannot use the drop the log trick because I have 2 logs, but then I also have a third term over here. The dropping of the log trick only works when you have a log equal to a log. And even if I moved this log to the other side, then I'd have a log equal to a log plus 1. So it ain't working. I can't use this trick. So what do? Well, this is where the last section that you practice condensing your logs down to a single logarithm comes into play. You're going to combine it to get, let's see, I always call it condense down to a single log. And then go to exponent land and solve it that way. That's how I'm going to do this one. They are being added. So that rule said you multiply these 2 things when you bring it together as a single logarithm. So this is going to be log base 5 of an x plus 6 times an x plus 2. still equal to the 1. And if you want to go ahead and simplify that, that would be log base 5 of, if I FOIL this out, I'm going to get x squared. I would get 2x on the outside, 6x on the inside. So my middle term is 8x. And then last times last is 12. Okay. So condense down to a single low. What the heck was I writing over there? Single log. Single log. That would be this part here. And now I'm going to, and then go to exponent land. That's what I'm about to do. I'm going to convert it. So you start with the base. The base is the 5. Guess I should have used a different color. Oh well. Remember, the base is your 5. So that goes here. And then you're going to raise it to the whatever the logarithm was equal to. That's this guy. And then that will be equal to whatever it was you were taking the log of. So pink, that's the 5. The blue is the 1. And then the yellow was the x squared plus 8x plus 12. I have changed it from logarithmic form to exponential. And of course, now I can see that 5 to the first is just a 5. And this is equal to a quadratic. So quadratic equations have to be solved. You set them equal to 0. Hope that they factor, because if they don't, you got to use the quadratic formula. So set it equal to 0. I am going to subtract 5 on both sides. Bada bing, bada boom. Follow me, I'm running out of room. So I got 0 on the left, and then x squared plus 8x, 12 minus 5 is plus 7. And I'm going to factor this to be an x plus 1 times an x plus 7. 1 times 7 is 7 for last times last. Outsides is 7x, insides is 1x. That adds up to the 8, which means my 2 possible answers for x are -1 and -7. Now, you might be inclined to think, wait, I can't have negative x's. No, you can have negative x's. You can't take logs of negative numbers. And if you look back at the original equation, it's the log of x plus 6 and the log of x plus 2. If you put -1 right here, -1 plus 6 is a +5. That'll work. I can take log of a +5. And if I put it here, does it cause any problems? Nope. -1 plus 2 is a 1. So this one should check. But when you plug in -7, -7 plus 6 is -1, and that won't check. So I would have to cross out this one. It doesn't check. It causes a negative. Causes a log of a negative. So that should be my only answer. Now that's me working it out, and I went ahead and left the slide in where it shows their methods, which aren't nearly as colorful as mine, but there it is. The answer is just x equals -1. Alrighty. And here's another one. All of the LOG rules work with the natural log rules. And when I look at this, I see that I have 3 logs. I got the log equals, the log minus the log. But On this side, I can condense it down to a single log. Okay, so I'm still going to have the natural log of x on the left, but then on the right, because there's a subtraction here, this is going to become the natural log of a division where you put the x plus 6 on the top and the x minus 4 on the bottom. Right? That's that rule. And now I have a log of this equals a log of that. So now at this point, I can drop the logs. I can use the drop the log rule. So just bing, bada boom. And so now what I have is x equals an x plus 6 over an x minus 4. And now I have to kick it into algebra mode. And I'm like, okay, how the hell do I solve this thing? Well, I've got a fraction where there's an x in the denominator. So let's take care of him first. I am going to multiply both sides by an x minus 4. So that the x minus 4s cancel out over here. On the right, however, or sorry, on the left, forgot my right from my left. On the left, I'm going to have to distribute the x. So this is going to be an x squared minus 4x equals, on the right, the x minus 4 is canceled out, and I'm left with an x plus 6. And in the process of getting rid of the fraction, Mr. X squared shows up, which says I now have to think about quadratics. So I'm going to set it equal to 0. So I'm going to subtract x on both sides so that that cancels out. And in the same breath, I'll subtract 6 on both sides so that that cancels out. So I'm going to have x squared and then a negative 4x and a negative 1x is a negative 5x. And then you'll just, it's like saying 0 minus 6. So this is a minus 6 equals, and of course, 0 on the right. And now I can factor. Okay, x and x. And then I need 2 factors of negative 6 that adds up to negative 5. Don't be grabbing 2 and 3 right off the bat. It's negative 6. So one has to be positive and the other has to be negative. The difference between 2 and 3 is a 1. We're looking for a negative 5. So I need 1 and negative 6. X plus 1 times an x minus 6 is x squared minus 5x minus 6. And now my 2 possible answers are, this one here can be a negative 1 and this one here can be a positive 6. And let's see if it causes any problems. Yep, if I put negative 1 right here, I can't take the log, so that one doesn't work. And if I put 6 here, I'm good. If you put 6 here, you're good. If you put 6 here, 6 minus 4 is positive 2, you're good. No negative problems there. So x equals 6 should be the only answer. And here's their explanation, and the solution set is just the 6. There you go. All right, which brings me to the other objective, which is solving exponential equations. And that is simply remembering this rule. If you have a to the u equals a to the v, then the u just equals the v. You got a to the this equals a to the that. You can use any letters you want. I usually use x to the a equals x to the b, so a equals b. But that method won't work here because this only works when your bases are the same, right? I have an a to the u equals a to the v, so you drop the base, or you drop the bases that are the same. If the bases are not the same, and cannot be changed to be the same, you must use logs to solve it. All right, so they give us an exponential, but I can't solve that exponentially. So we're going to go in reverse. Before if we had the log of this equals a log of that, we just drop the logs. Well, we're going to put the logs back in. So let's see, step 1. Take log of both sides. Because you know what you do to one side, you can do whatever you want as long as you do it to the other. So I'm going to take the log of both sides. So I'm going to have the log of 5 raised to the x plus 3 equals the log, the log of 3 to the 2x minus 5. Okay. Step 2. I'm going to move those exponents. This x plus 3 right here is going to go out in front, and this 2x minus 5 is going to go out in front. We're going to use that rule, that log rule. So this is going to be, and since I'm moving it as a binomial, the entire binomial has to go in front of the log of 5. Same thing with the 2x minus 5. It's got to go in parentheses. Okay, I'm running out of room fast, so what I'm going to do is just go to here and show you. Oh, they did natural log. Whatever. I did log. Okay, so once they did that, you can see that they took the log of both sides right here, right? Log of this, log of that. Then they moved the x plus 3 to here, and the 2x minus 5 to here. And then they distributed the natural log of 5. So they took the natural log of 5 times x, here it is, and then the natural log of 5 times 3. So 3 natural log of 5. Same thing over here. It's 2 natural log of 3, and then they put the x out here because you're solving for x. So that's why they did that. And then here, 5 natural log of 3. And then what they did is you're trying to solve for x, so they put any logarithmic terms with x on the left side of the equation and any logarithmic terms without x on the right. So they, let me erase these lines here. There. So they subtracted the 2 natural log 3 of x from both sides here, and then here it is on this side, and then they subtracted the 3 natural log of 5 to cancel it out, and it shows up over here. They did it on both sides. And then when you get your two terms with x's on the left, you're actually just going to factor out the x. And they factored it out in the back for some reason. But you've got ln of 5 times x minus 2 ln of 3 times x. So they factored the x out. And they are left with ln of 5 minus 2 ln of 3, which they then proceeded to divide off on both sides. So let me get a gray pen here. They then divided both sides by natural log of 5 minus 2 natural log of 3. Natural log of 5 minus 2 natural log of 3 cancels out there, and you're just left with x. And then basically you're left with this mess. And they just copied it down. Negative 5 ln of 3 minus 3 ln of 5 all over ln of 5 minus 2 ln of 3. Now, my math lab, you're going to have a question where it asks for an exact solution. And when they want the exact solution, that means they want you to leave it in terms of logarithms. So this mess right here is your exact solution. Then they want you to do an approximate solution. An approximate solution, and that's when you're going to grab your calculator and have fun plugging it all in, and then round it off to whatever they tell you to. All right, so I've got 8 questions here to go through. So let's get to what you're going to face in my math lab if you're ready. Hey, start out simple and then get progressively more difficult. Okay, log base 5 of x is equal to 3. I cannot solve this using logarithms because there's only one logarithm. So when it's a single logarithm, you are going to change it from log form to exponential form. And you're going to start with the base of 5. That's going to go here. And then I'm going to raise it to the power of whatever your logarithm was equal to, and then it's going to equal whatever it is you were taking the log of, and we were taking the log of this x right here. So it's log base 5 of 3 equals x, and this one's already set equal to x. All I have to do is calculate 5 to the third, which is 125. And that's my answer, which will go in this box right here. Just type the number 125. You don't have to type x equals because they're using, you know, braces here. They just want the numbers. Okay. Number 2 has log equals log, which means I'll be able to drop my logs, but I have this 2 in front of that log and this negative invisible 1. So those have to go back up into their exponent positions. So this is going to be log base 5 of an x to the second equals log base 5 of a 25 raised to the negative 1. And now I've got log base 5 of this equals log base 5 of that. And I can just drop the log base 5s and set these two things equal to each other. So x squared equals the 25 to the negative first. And of course, 25 to the negative first, if I drop that, that will be 1 over 25 to the positive first. Which is just 1 over 25. And then I'm gonna square root both sides. So I get an x squared over here, and technically it's a positive or a negative. The square root of 1 is 1. The square root of 25 is 5. So those are my two possible answers. However, if you are going to plug, I get these two possible answers. If you plug in the negative one right here, it won't work. So my only true answer is positive 1/5. That's my only answer, which will go here because you can't take the log of a negative. Neg doesn't work. Negative doesn't check. All right. This one, I got log plus log equals 1. So I can't use the log of this equals the log of that rule because I got that third extra piece, the 1. So I'm going to condense it down to a single logarithm. And because they are being added, I will multiply the x times the x plus 9. And this is just log, that means it's base 10. So if it helps, put the base 10 in here to remind yourself it's base 10. And then this is going to be an x times the x plus 9 equals the 1, which means base 10 to the first power is going to equal the x times the x plus 9, which if I go ahead and distribute that, that's going to be x squared plus 9x. And then, of course, 10 to the first is just 10. And it's a quadratic, so I got to set it equal to 0. I'm going to subtract 10 over. So this is going to be 0 equals x squared plus 9x. And here comes the subtract 10. I subtracted it on both sides. And factor. So it's x and x, and then I need two factors of negative 10 that add up to positive 9. So positive 10 and negative 1. Which means my two possible answers are, this would be x equals negative 10, and this would equal x is positive 1. 1 won't cause a problem if I put a 1 here and a 1 there. We're good to go. It doesn't cause any negatives. It should check. But if you put a negative 10 in either one of these places, they're both logs of negatives, so that doesn't check. So 1 is my only answer that goes in there. At first glance, it looks like you've got a log equal to a log, but you don't. You have a log equal to 3 minus a log. So this one is very similar to the last one, except I have to move my log on the right over to the left, on the left side of the equal sign. So I am going to add log base 3 of an x plus 22 to both sides. Well, that's messy. Okay. So this is going to be log base 3 of the x minus 4. And then here comes my plus log base 3 of an x plus 22. And then it's going to still equal just the 3 because this and this canceled out on that side. Now I'm going to condense it down to a single logarithm. because they're being added right here, you're going to multiply your x minus 4 times your x plus 22. So it's a single log. Actually, I'm going to go over to the left here, give myself more room. I'm going to have log base 3 of the x minus 4 times the x plus 22, and that'll equal 3. Got it down to a single logarithm. And now I can convert it from log form to exponential. Pack your bags, kids. We're going to exponent land. I've always thought about making a game called Mathland, you know, like Candyland. But instead of Mr. Licorice, it's Mr. Logarithm. And instead of Queen Frostine, it's, you know, the math goddess, April. Okay. So I grab my base. My base is the 3. This 3 over here is my exponent, and that is going to equal the x minus 4 times an x plus 22. And 3 cubed is 27, and then if I FOIL this out, I get x squared, a positive 22x, and a negative 4x is a positive 18x. And negative 4 times 22 is negative 88. And we're into the quadratics, so set it equal to 0. Okay, I'm gonna subtract 27. And now I got 0 equals x squared plus 18x minus 115. And believe it or not, this does factor. Took me a minute to find the 2, but I found them. The 2 factors are a plus 23 times a negative 5, and that would add up to the positive 18. And now my 2 possible answers are this one here, x is negative 23, and this one here is x is 5. But if you plug in a negative 23, if you plug in a negative 23 here, you're going to get negative 23 minus 4, which is negative 27. And then you can't take the log of a negative, so that one's out. And you got to check both, because sometimes you can see right here, it says there is no solution. That's an option. So, but if I plug in 5 right here, 5 minus 4 is 1, I'm okay. And 5 plus 22 is 27. Those are both positive numbers. So this should check. It should check. Only negatives cause problems. So, but just because it's negative, you got to plug it in, because I got a binomial up there of x minus 4 and an x plus 22. You know, negative 20, if this had been a negative, I don't know, 3, it wouldn't cause a problem here. It still would over here, but you always have to check it. So my answer is just 5. Let's see, that was number 8. All right, number 9 is a doozy. So if you don't mind, I'm gonna skip over it for just a minute and see if I can do these other 3 real quick. It's a doozy. So I didn't realize that until I started working. I was like, son of a bitch, because I got to use a quadratic formula on it, and they want both the exact and the approximate answer. So number 11. Okay, I got log of something minus log of something equals -1. So I have to condense it down to a single logarithm and then convert it to exponential form. They are being subtracted here. So I have to use the log rule that says divide. So it's log base 1/5. And then my numerator will be the x squared plus x, and the denominator is the x squared minus x. All of that equals the -1. And now I've condensed it to a single log, so I'm going to convert it from log form to exponential. So I grab the base, that's 1/5, and then that is going to be raised to the power of whatever the logarithm was set equal to. And then that is going to equal whatever it was that you were taking the log of. And you were taking the log of this mess right here. So that's what's going to go right here. Yuck. So 1/5 raised to the -1st, and that means all of 1/5 is going to equal an x squared plus x all over an x squared minus x. Now, follow me. If you have this 1/5 to the -1st, if you flip the 1/5 over, then you have 5/1 to the +1st. If you flip this over, this will be 5/1 to the +1st, which would be just 5 to the 1st would just be 5. So now what I have is 5 on the left equals, so this all here gives me this 5, equals the x squared plus x over x squared minus x. So I've successfully left log land and went to exponent land and simplified my exponent, but now I've got to deal with a fraction. So I'm dealing in fraction land. I got to clear out the denominator. Oh boy. So I'm going to multiply both sides by the x squared minus x. So that cancels that, leaving you with just the x squared plus x on the right side. But on the left side, I'm going to have to use the distributive property. I'm going to distribute the 5 here and here. So that's going to give me 5x squared minus 5x on the left. So this is a quadratic equation. I got to set it equal to 0. It doesn't matter which side your 0 is, but in my professional opinion, for what that's worth, it is always easier to factor or use the quadratic formula when your x squared is positive. So I am going to subtract x squared from the right side, because when I subtract it from the left side, I'll have a +4. So I'm making 0 on the right. So I have to subtract my x squareds, but I also have to subtract this x to cancel it out. So I'm going to end up with 4x squared minus 5 and minus 1 is minus 6x equals 0. And then factor, the only kind of factoring I can do on this is greatest common, where you just suck one thing out. They're both divisible by a 2 and an x. So I factor out the 2x, and then I'm left with, inside the parentheses, 2x minus 3. So my two possible answers are either the 2x is equal to 0, which means if you divide 0 by 2, you get 0, or the 2x minus 3 is equal to 0, which means I'd have to add 3 and divide by 2, so I get 3/2. And you should check them. If I plug 0 in here and 0 in there, I get log base 1/5 of 0, which would be a 1, minus, and if I stick 0 in here and 0 in there, I get log base 1/5 of a 0, which is 1, but 1 minus 1 equals 0, not -1. That doesn't check. And then the 3/2, let's see, 3/2 squared plus 3/2, that will be okay. And 3/2 squared is 9/4 minus 3/2, which would be 6. Yep, that's okay. This doesn't cause any negative problems or any zeros like that. So 3/2 is the only answer. So I'd click on this and type in 3/2 and get my positive affirmation. All is well with the world. All right, and then this one is exponential. It says solve the exponential equation. Well, my base on the left is a 3, and my base on the right is a 6, right? I got base 3 and base 2.6. The bases are not the same. And there's no way I can force them to be the same. 2.6 is not a base 3 number. So use logs. And you can do LOGs or LNs. It really doesn't matter. I prefer LOG because that way I don't know, I just prefer it. So I'm going to take this 3 to the negative x equals, and then this 2.6, and I am going to use logs. I'm going to take the log of both sides. Now I've got the log of 3 to the negative x equals the log of 2.6. But I can't leave this -3 here. He's got to go out in front. So now I'm going to have, did I say negative? Whatever I said, I meant to say -x. I think I said something else, sorry. The -x goes out in front times. Now you've got the log of 3 equals the log of the 2.6. And you're solving for x. So I'm going to, I just looked at my paper and realized I could have done this a much easier way. Damn. My daughter's giving commentary over there. It's enough out of the peanut gallery. Crap. Can I start over? Yuck. I don't like that method. Try again. I am going to use logs, but I'm just going to change it from exponential form to logarithmic form. This is going to be log base 3 of the 2.6 will equal the exponent of -x. That's so much easier. It's sort of solved for x. It's actually solved for -x. So you would have to divide both sides by a -1 so that you get a positive x over here. And then what you have is a negative log base 3 of 2.6. Now, I have successfully solved for x, but my math lab in usual form gives me some weird ass directions. It says simplify your answer. Use a comma to separate answers as needed. Use integers or fractions for any numbers in the expression. 2.6 is a decimal. Here's my problem child right there. My math lab won't take that. So what the heck is 2.6? Well, let's see. Let's go back to basic math here. 2.6, isn't that the same as 2 and 6/10? but that would be 2 3/5. And that's not a fraction. That's a mixed number. So you've got to change it. If you remember how to do this, you take the denominator times the whole number and then add the numerator. So 5 times 2 is 10 plus 3 is 13, and then you still have it over the same denominator of 5. So 2 3/5 becomes 13/5. So my final answer in my math lab is going to be negative log base 3 of 13/5. And if you need to put it in parentheses, go ahead and do it so you don't get it confused. Equals x. And then number 14. Okay, this one I do have to take logs of both sides. All right, I could have done it on this one, but it was so much easier to just do it this because you only had one base, one exponent, and then something that it was equal to. So you had those 3 components that I usually highlight in pink and turquoise, blue, and yellow, you know. But on this one, I've got 4 components. I got 2 bases and 2 exponents. So on this one, you do have to take logs of both sides, unfortunately. So I'm going to have to go log of the left side, which is 3 to the 1 minus 6x, equals log of the right side, which is 7 to the x. That's step 1. But I've got this guy here is an exponent and this guy here is an exponent. So we're going to have to fly them out in front. So I'm now going to have, and it's a binomial, put it in parentheses, 1 minus 6x times the log of 3 equals x times the log of 7. All right, now I'm going to have to distribute the log of 3 to clear out my parentheses. So 1 times a log of 3 would just be a log of 3. And then minus 6x times a log of 3 would be minus 6x times a log of 3 equals x times the log of 7. Keep in mind, you're solving for x. I have 2 terms with x's in them and 1 term that doesn't. So the 2 terms with x's have to be on the same side. They are not. One of them's on the left, the other one's on the right. So I'm going to get them all on the same side. I am going to add 6x times a log of 3 to both sides. So it cancels out there. So I'm just going to be left with the log of 3 on the left. And then on the right, I'll have the x times the log of 7 plus 6x times the log of 3. Now, those are not like terms. In order to add x's, you'd have to have like 5x plus 2x, that's 7x. Well, what I have is the log of 7x plus 6 to the log of 3x. Your logs would have to be identical. And I don't have that. Like if I had 1x log of 3 plus 6x log of 3, I would have 7x logs of 3, but I don't. So the only way to solve for x now is to factor out the x. So I'm going to have the log of 3 equals, and then you've got an x here. That is too thick. There we go. I've got an x here and an x there. I'm going to factor out that x. And when I do, that's going to leave me with the log of 7 plus 6 times the log of 3. I pulled the x out. And now, in order to solve for x, I'm going to divide both sides by all that junk in the parentheses. I am going to divide by log of 7 plus 6 log of 3. So that cancels that. Let's see, the solution set is blank. Simplify your answer. Use a comma to separate answers. Use integers or fractions for any numbers in the expression. Type an exact answer. They don't want you grabbing your calculator and figuring out what the decimal value of this mess is. You have to type into my math lab a fraction with the log of a 3 in the numerator. And then your denominator is log of 7 plus 6 times a log of 3. It ain't pretty, but that's the answer. Now I'm going to go back to, where was it? Number 9. I got 3 minutes. I'll probably go over because I want to finish this. So if you have to leave at 5:15, leave. But I should really get done in about 5, 6, 7 minutes. All right. This has log plus log equals not a log. So I have to condense it down to a single logarithm. And because you are adding right here, you're going to multiply. So this is going to be the natural log of, you're going to take the x times the x plus 8. And that'll still equal the 3. Now, because they're using natural logarithms, you have to remember that your base is really an e right here. So when you convert it from logarithmic form to exponential form, it is a base e raised to the 3rd, and that is going to equal the x times the x plus 8. Now, way back at the top, it says solve the following logarithmic equation, express irrational solutions in exact form, and as a rounded decimal. And then it says verify your results using a graphing utility. We're not doing that. We don't have graphing utilities. That's a graphing calculator, so not that part. So exact form means they want me to leave it in terms of e. All right, well, first things first, get rid of the parentheses. So I distribute. I get x squared plus 8x. That's a quadratic. I need to set that equal to 0. So I'm going to subtract over the e cubed. You are not allowed to grab your calculator because remember, e is really 2.87 blah, 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 something or other. And I have to leave it in exact form, which means I have to leave that e in there. You cannot factor. You have to use the quadratic formula. So when I'm looking at this, I'm like, okay, my a is a 1, my b is an 8, and my c is a negative e cubed. Then you got to remember the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's going to be negative b. B was 8 plus or minus the square root of 8 squared minus 4 times A is 1 times C, here's the fun part, is a negative E cubed. All over 2 times 1. All right. Let me add a slide here. Blank slide. Okay, so I'm going to simplify that up a little bit. X is going to equal, it was -8 plus or minus. 8 squared is 64. And then it was minus 4 times 1 times a negative E cubed. Well, a minus times a minus changes that to a plus. And 4 times 1 times E cubed is a 4E cubed all over 2 times 1 is 2. Now, I can't add 64 plus 4E to the third. I can't add these. These are not like terms. But I can factor out, underneath the radical, I can factor out a 4, which is a perfect square. 64 divided by 4 is 16. And 4E cubed divided by 4 is an E cubed. Still all over 2. I can take the square root of that 4. And when I do, he is going to come out here as a 2. Unfortunately, the 16 plus E cubed has to stay underneath the radical because, yeah, I know 16 is a perfect square, but order of operations, it's as if all that's in parentheses. So you'd have to cube your E, then add it to the 16, and then the last thing you would do is square root. So don't be trying to take the square root of that 16. You violate order of operations when you do that. Now, once I pull out the 2 from the 4, I can, at this point, simplify because I can divide 2 into the first part, and I can also divide 2 into the second part. -8 divided by 2 is -4, plus or minus, and then 2 divided by 2 is a 1 times the square root of 16 plus E cubed. Okay? And this is actually 2 answers. -4 plus 1 times the square root of 16 plus E cubed, and -4 minus 1 times the square root of 16 plus E to the 4th. And I can tell you right now that the minus isn't going to check, because if you do -4 minus all of this stuff, that's going to equal a negative number, which won't check in, where was the original logarithm? Yeah, right here you have a log of x. If your x is a negative number, it won't check. So the -4 minus crap doesn't check, which means the only answer I'll type into my math lab as an exact answer will be -4 plus, that 1 is really invisible, 16 plus E cubed. Whew. Now that's the first part. So you enter it in, my math lab's like, good job. And then it pops up and it says, all right, give me the estimated and the approximate answer, and they want it to the nearest thousandth. So I'm going to grab my calculator next. I'll use another slide for this. All right, so grab calculator. And in order to do this mess on the calculator, which I have to punch in negative, this is what I'll be doing on the calculator. but your calculators, I have to start under the radical. I have to actually start with the number 3, start with the exponent. Then you're going to hit your second button, which will either be in yellow or green, depending on your calculator, right? And then you're going to hit your LN key, because written above it, it says e to the x. Then you're going to hit the addition button, and then you're going to hit 16, and then you're going to hit your equal sign. And at that point, you should see on your calculator 6.007123848, but keep going. Next, after you hit the equal sign, that's what you'll see. Then you're going to hit your square root button, because it'll take the square root of that 6.00 number. And then I have to do this adding of -4. So I'm going to hit the addition button. I'll hit the 4, and then at the bottom of your calculator, you'll see a plus/minus sign with arrows like this. That'll put the negative on the 4. And then you hit the equal sign one more time. And now you should see 2.007123848. And they want it to 3 decimal places. So 1, 2, here's the third decimal. The next number is a 1. So the approximate answer will be 2.007. And that'll be your second answer. Okay, it took me an extra 7 minutes. And now I'm done. Whew. Questions on that? Looking rough. If not, bye. I'll see you Wednesday. Okay. Let's see. End.